Let's start with electric flux. When we place an element of an area in an electric field, some of the line forces pass through it. The number of the field lines passing through a certain element of area is known as electric flux through that area. It is usually denoted by a Greek letter phi. For example, the flux phi through the area A in the figure 12.3a is 4, while the flux through B is 2. In order to give a quantitative meaning to flux, the field lines are drawn in such a manner that the number of field lines passing through a unit area held perpendicular to the field lines at a point represent the intensity E of the field at that point. Suppose at a given point the value of E is 4 Newton Coulomb inverse. This means that if 1 meter square area is held perpendicular to the field lines at point, 4 field lines will pass through it. In order to establish relationship between electric flux phi, electric intensity E and area A are considered. We consider the figure 12.3 BCD, which shows the three-dimensional representation of the electric field lines due to the uniform electric field of intensity E. In figure 12.13 B, area is held perpendicular to the field lines, then EA line passed through it. The flux phi E in this case is EA, where A denotes that the area is held perpendicular to the field lines. In figure 12.13c, area A is held parallel to the field lines and is obvious no line cross this area. So that flux in this case is EA is equals to 0, and A parallel indicates that A is held parallel to the field lines. Figure 12.13d shows that the case when A is neither perpendicular nor parallel to the field lines but is inclined at an angle theta with the lines. In this case, we have to find the projection of the area which is perpendicular to the field lines. The area of this projection is A cos theta. The flux phi in this case is EA cos theta. Usually the element of the area is represented by the vector area A, whose magnitude is equal to the surface area of the element and whose direction is direction of normal to the area. The electric flux phi E through a patch of flat surface in terms of E and A is given by EA cos theta E dot A, where theta is the angle between the field lines and the normal to the area. Electric flux, being a scalar product, is a scalar quantity and its SI unit is Newton meter square Coulomb inverse.